Hey guys, I'm Rahul Tiwari. So welcome to the session, and this particular session we are going to talk about Python OOPS concept. OOPS is nothing but object-oriented programming language. So what is the agenda? The agenda is nothing but we have to talk about the introduction of Python, features of Python, installation, how can we install Python, then OOPS in Python, where we will talk about four different concepts: inheritance, polymorphism, encapsulation, and abstraction. So what is Python? Now Python is a programming language which is an open source programming language, and it is easy to learn. It has lots and lots of libraries, right? So it's a package driven programming language. The main benefit of this programming language is just that it is very easy to learn. So if I want to create a variable in Python, obviously I have to create a single line, less than a single line in Python. However, in Java, we have to write 4 or 5 lines of a code. So if you want to get to know if you guys are from Java, so how to create declare variable in Java, right? If you see here, there will be some images. So to create any variable, you can see clearly we will have to write lot many lines of code. Let me show you just. So for example, let's say here we are creating a variable f name, l name, favorite color, integer, age, and so on, right? So you can see one, two, and then all the variables, and then this lot many options, like lot many lines of a code we have to write. Now in Python, we just have to write a single line. So that is the main benefit here. And again, it's a package-driven programming language. So obviously, it is like a very easy thing. Suppose I want to take a square root of a number. Simple example. I can call a package and it will able to do it, right? I don't have to explicitly write any function, or I don't have to explicitly do any coding. So it is just an example, but let's say I want to do some more complicated operations. In that case, again, there will be a lot of packages available which takes care of these things. This is the guy who discovered or who created Python, and his name is Gaudio van Rossum. He created in 1989. Suddenly, there is a big buzzword coming in for Python, right? Python has topped the list in 28.73 share in popularity. In last 5 years, Python has had 18.2% growth, right? So that is the only thing which you can see here. And obviously, there are a lot of jobs available as well. The only reason is that I can do a lot of things using Python. I can do automation using Python. I can do data science using Python. I can do machine learning using Python. I can do artificial intelligence using Python. I can create a website using Python. A lot of things we can do, and that is the main benefit of this particular programming language. Big companies like Google, Quora, Dropbox, BitTorrent, Instagram, YouTube, these are like using Python a lot for their day-to-day work. NASA, like there are lots and lots of organizations who are using Python. Also, why it is very much popular? Because the reason of popularity is the packages which is it has, right? So machine learning AI I cannot achieve through Java, right? The extensive library is not there. But if I talk about Python, TensorFlow, Keras, these are the packages which are helping us to achieve all these stuffs in quick and easy way. So you see that these are the various packages: NumPy, SkyPy, TensorFlow, Keras. These are some of the popular packages which are available in Python, which is helping us to make things easy and faster. Features of Python we already discussed quickly: simplicity, open source software, then it's a portability. Suppose my code is in Mac and I want to execute that code in Windows as well. No issues. Just move the code in the machine, Windows machine, and you will be able to do that. Embedded and extensible. Then we have interpreted programming language. Here I don't have to call, what do you say, interpreter. Python will automatically understand and execute the command. If I talk about this embedded and extensible, so I can run other programming languages codes, for example, C, C++ in Python. Same way in C, C++ Python, I can run Python code as well. That is the benefit which we have, that extensible and embeddable language this is. Then, as I mentioned, there is a packages, libraries such as NumPy, Matplotlib, scikit-learn. These are some of the very, very important libraries for data science, machine learning point of view. It's a huge set of libraries which are available. It has OOPS, object-oriented programming language, right? So OOPS is again one of the techniques which we can apply in the programming and make things which are very much complex to a simple step-by-step programs. Now, how to install Python? To install Python, we have various ways. I prefer to go with one is from Python website, which I don't want actually that you guys install Python from Python website. The only reason is that the packages which I am talking about, NumPy, Pandas, all those packages, you have to install separately if you install Python from Python website. That's why the best is anaconda.com. You can go to anaconda.com and you can very well download from here. Go to individual edition, and then if you go till the end, you can see your data science toolkit. It is helping us understand that these are the packages by default comes in once you install Anaconda. By default, these will come. You can see below, based on the machine, you can download the Anaconda instance. Go with the latest version of Python because the support for Python 2.7 is no longer there. So better to go with the latest version based on the bit of the machine. Also operating system, whether it is Windows, Mac OS, and Linux. Based on that, you can go for it. Once you download that, then you will just have to write Anaconda. You see there are two options coming in: Anaconda prompt, which is nothing but a command prompt, and this is Anaconda Navigator, where you can launch the graphical user interface like Jupyter Notebook and Spider. We will going to use Jupyter Notebook for our this class. If I go to Anaconda prompt, you can see that this is nothing but a command prompt which I have. I already mentioned that when you install Python from Anaconda, the relevant packages which are on data science, you will able to get those packages here. PIP list. You can see that we have the packages coming in. Right here, you can see that we have scikit-learn, we have pandas, all these packages coming by default. Right. Anaconda is a distribution system. From there, you will get the GUIs where you can do coding. For example, Jupyter Notebook and Spider. PyCharm also coming in. So basically, Anaconda is now coming up with PyCharm as well. Right. So PyCharm is one of the GUIs which people use, but I prefer to go with Anaconda like Jupyter Notebook and Spider because in industry people are using that more as compared to PyCharm. And now in Anaconda PyCharm from this year it will also come in. So for example, if I install Anaconda, PyCharm also by default comes in with Anaconda. Right. So if you see here, if I go to Anaconda Navigator, it will show me all the graphical user interfaces, and it will take some time. So Spider, Jupyter Notebook, those are like the places where I will do the coding, and from this year PyCharm will also be a part of it. It will take a little bit of time. In the meantime, let's proceed. Here we go. Okay, you see this is my Anaconda Navigator. You have Jupyter Lab, you have Jupyter Notebook, you have Spider, IPY console, right? A lot of options we have, and here you will most probably see Anaconda PyCharm as well soon. Now, if I go ahead and this is my Jupyter Notebook, once you open Jupyter, this is how it will look like, and this is the page of Jupyter. You can see here. This is the Jupyter Notebook. The name Jupyter comes in with JU for Julia, PY for Python, R for R programming. So basically, there are three programming languages which can be run using Jupyter Notebook. That's why this is named as Julia, uh, Python and our Jupyter. Now, if I go to OOPS concept directly, right? So what is an OOPS concept? So basically there is a concept of classes and objects, and there are concept of methods as well. So we'll quickly talk about that. I have object, class, and method. Now what is an object, what is a class, and what is a method? I'll take an example. Let's say I have a blueprint of a house. Once, let's say I am creating a big society, right? We will not start creating the society directly. We have a floor plan, and we'll have like, okay, here the kitchen will be, here the bedroom will be, and so on. I'll have the floor plan like this, right? And then once the floor plan is ready, then we start building the houses. So basically this floor plan is nothing but class. And when I am creating a physical object, then it is an object. So with this class, I can create multiple objects. With this plan, I can create multiple houses. So class is one. I'll have multiple objects for that class. Okay. So now if I try to create a class here, let's try to create it. So to create a class, we have a command called class. Let me take one example. Let's say I'll take first one example and try to help you understand that. So we are creating a class called student, right? So the syntax for creating a class is class, then student, and this we prefer to go with a capital letter. Obviously, the class will be created, but syntactically or programmatically, we prefer to go with capital letter. Def init self comma name comma marks. Now what is an init? Init is nothing but it's a constructor. Okay, so this init method, so basically we are creating a function inside a class, and this method is known as constructor, which is helping us to initiate the instance variables. This is my instance. In this instance I have a variable called name and marks. That is how the syntax is. This is how we call the constructor. Init underscore underscore init underscore underscore is what I can use. Now, question arises, what is this self? Self is nothing but it is again an option to, let me create the entire code, then it will make more sense. So what I will do is I'll go ahead and call this entire code, and let's say I'll give some conditions here. For example, self dot name is equal to name. So self is a keyword which is helping us to initiate, like this constructor is helping us to initiate the variables, instance variables of a class, and self is a keyword which is helping us to assign that variable in the name, right? Self dot name. So this self is helping us to assign the variable in this particular variable, assign this name variable in this particular variable. After that, we have self dot marks is equal to marks. Now, what I want is I want to create one more. Self is not necessary to use, but you can give any name. You can put Edureka also, but it is required. Something is required here. You can give any name, but self is a best programming practice. That's why we go for it. So it is helping us to assign the variables inside this method. After that, we have, let's say we have to create a new method. So basically, what is this? This is a constructor, and then def display self. I'm calling this self again. Print hi comma self dot name. Print. If you are calling a constructor, guys, then this self is required. We cannot skip this. Print your marks is self dot marks. Now, after this, what I want, I created a class called student. Inside that, there is a method. This method is known as constructor. This method is known as instance method. So now if I go ahead and create an object from a class, if I execute, it will throw me an error because it is looking for name and marks. You can have constructor without parameters, absolutely no issues. So my name is, let's say, I'll put John, and marks is, let's say, 45. So an object is created which is s, and this object will have this function as well, because I created an object s with a class student, so all the features which we have in this class will go to this object as well. So dot object, sorry, dot display is the feature, right? If I execute, it will print me the marks. Suppose I want to create one more method, def grade. I want to assign a grade, self, and then if self dot marks, let's say, is greater than equal to 60, then print you got first grade. If self dot marks is greater than equal to 50, print you got second grade. Else, let's say, just give print you failed. Okay, so I created a new method inside the class, and if I call s dot grade, it will help me to decide what is the output. You failed. Okay, if I go ahead and make 65, it will say get first grade. So you can very well play around with the condition and you will get the output. Okay, so that is an idea about a class, a method inside a class. This is nothing but init is a constructor, display is a method inside the class. When you want to initiate the variables, then this is nothing but helping me to initiate the variables. If we want to do some calculations or some logic building, then we'll have this methods. I created one student, I can create multiple students. For that, we have to run a loop. We are using self in other methods because we have to pass the variables, right? We have to pass the variables which we are initiating here, and these variables can be passed through self because now it is assigned to a self, and then I can very well call these variables. Grade also is a method, absolutely. I can have multiple methods, and these methods are known as instance methods. Okay, there are different type of methods again: instance, static, and class methods. These are like instance methods. I'll jump to inheritance, which is a concept which I want to talk about. So what is an inheritance and how this works? What are the different types of inheritance? Let's say I have, what inheritance means. Basically, I have a parent and my parent is giving me my all their properties, right? So they are inheriting their property to me. That means all the features which they have, they are inheriting to me. However, I will have my own features as well, right? I can have my own features as well. So in that case, I will have the property of mine as well as their property. So what are the different type of inheritance, and we'll see see the syntax how it works. If you are using self, it should be self all over the place. If you are using any other variable, it should be other variable all over the place. Types of inheritance. The first type is single inheritance. Now what is single inheritance? So basically, I have a parent and I am a child, one-to-one relation. Then it is a single inheritance. I'll show you the syntax for it. Second is multi-level inheritance. One parent give the property to child 1 and child 1 is giving the property to child 2. Okay, so basically if I try to explain in the paint, I have a parent and there is a direct relation with the child, then this is single inheritance. Let's say I have a parent He is giving me the property, and I am giving the property to another person. Let's say my father is giving me property, and I am giving the property to my child. So it is multi-level. Then there is a concept of hierarchical inheritance, parent, and I have child 1, child 2. Okay, so let's say my father, I am one of the son, and maybe my sister. So here we have hierarchical inheritance. And next is multiple inheritance. Now what is that? Two parents I have. Parent 1, parent 2. And child is getting properties of both the parents. That is multiple inheritance. Okay, so these are the four main types of inheritance which we have, and how we can create a syntax. So basically I'll try to help you understand the syntax, how it will be created. So to create a single inheritance, let's say class P is my parent. It has some method. Now here self, if you remove, that is fine, absolutely no issues. But I'm passing it and print parent method. Okay. So I have a class P. Inside this class P, this is one of the properties of the parent. Now I have a class C, and I am passing parent property colon pass. Now what is the property of C? C has this C has its own property or not? We don't have any C property, right? C is like just a standalone class. I don't have any like C as a child don't have any property. So if I go ahead and create a class object, and then when I check C dot and tab, M1 automatically coming in, and you can see that it is helping us to find the details of parent. So basically I called a class C. C has a property of parent, and parent has a property def M1. So automatically that property assigned to C. C does not have its own property. Does not have its own property. It is just getting the property of the father, parent. Now let's say I'm giving some features to this child also. Print child method. Right? Now what all properties? Pass is like I don't want to run anything, just pass. Simple keyword. Like if I'm creating a class and then I'm passing it, I don't want to execute anything here, it is just pass. No properties I have, just pass it. Now C dot, you will see that I have M2 also coming in. Okay, so that is how you will able to get it. Now what is the second type of property, which is multi-level? Class P def M1 self print, let's say parent method. Then I have another class C def M2 self print child method, and I have another class CC having the property of C def M3 self print sub child method. So what happened here? I have a parent giving the property to a child, and child is giving property to subchild. Now if I will create a object, C is equal to CC, it will have all the property of CC, C and P. So if I check C dot M1, or let's first write C dot M3, it's running fine. C dot M2, it is also running fine. C dot M1, it is also running fine. So basically CC has all the properties of above parents, and this is known as multi-level inheritance. There is no limit. I can have multiple relations, but in industry standard, we prefer to go with maximum 6 to 7 hierarchical, right? 6 to 7 multi-level basically. Now class P. Now I'm talking about hierarchical inheritance. I have two childs, right? I am a parent. I have two childs. So def M1 self print parent method class C. I am giving property to this class C. Def M2 self print child method class CC P def M3 self print sub child method, right? Now C is equal to, if I will call C class, now what all property C will have? C will have M2 and M1. Okay, M1 is a function and this is known as method. Basically, when we are talking about object oriented programming language, then this is mentioned as method. It's a sibling obviously, so ignore that, child 2, because it is getting property from parent only. C is not giving the property. Now C dot M2, if I execute, you see child method coming in, obviously this one. C will have M1 also, parent method, absolutely no issues. Will C have M3? No, right? C dot M3, it should not be, ideally, obviously it does not have. Now I'll create CC equal to CC. Now what are the things CC will have? M3 and M1. So CC dot M3, yes, looks good. CC dot M1, yes, looks good. Will we have CC M2? I don't think so. You can see it's not there. Okay. So what is the difference between multi-level and inheritance? So this is what this is what I have parent giving property to both the childs. So it's a hierarchical. So parent giving property to two childs. This is hierarchical. If I go to multi-level, then what's happening? Parent giving property to child and child giving property to his child. Okay, that is multi-level. So here I have only one parent and two childs. However, here my father gave me the property, I gave the property to my son. Here it's like Mukesh Ambani, Anil Ambani. Dhirubhai Ambani, Mukesh Ambani, Anil Ambani. Now, multiple inheritance. Now, what is multiple inheritance? Now I have two fathers. My God. And I'm getting property of both the fathers. Okay. So that is what multiple inheritance is all about. Let's say I have class P1 def M1 self print parent 1 method. Similarly, class P2 def M2 self print parent to method. Okay. Now the child comes in. Here I have P1 and P2. My child is C. And then def M3 self print child method. Okay. Now what will have? What we will have? C should have property of its own M3. C should have property of M2 also, which is coming from parent 2, and C is a property which is coming from parent 1 as well. So if I go ahead and create a object C, and if I call C dot, let's say M3, looks fine. C dot M2 looks fine as well. C dot M1 looks fine as well. Okay. So Python have multiple inheritance like C++. I don't know C++. I'm not from C++ background, but yes, this is how it works. This is my multiple inheritance. Okay. So these are the different types of inheritances which we have. Now, based on this knowledge which we have, we'll try to create one logic. Right? As of now, we got to know the syntax. Maybe we can create a small example so that we'll get an idea how it actually works. Let's say how Python resolves diamond problem. So basically, there is a concept of MRO. That is what Python uses to resolve the diamond problem. Right? Let me create a small simple example so that it will be easy. Let me go ahead and create one. I have a class person. Or let me do one thing. I have one example already ready with me. I'll just quickly show you that. Here is one example. Here you will understand the concept of encapsulation as well. This is underscore underscore width underscore underscore height. This is nothing but my encapsulation. Basically, I am trying to make this as private variable so that only this class will able to access this variables. Okay, so that is encapsulation. I'll just copy this code. Okay, so now what we are doing here, we have created a class called polygon which has an input we have to pass. Now this is a private variable which cannot be accessed directly. For that there is a concept of setter and getter. If we want to set the value, we have to call a setter which is helping us to set the value of width, set the value of height, and then I have to get the value of width and get the value of height. So you can see that I'm using getter somewhere here to get the value, right? Here you can see get width, get height, get width, get height. So if you want to access this private variable from one class to another class, then you have to call a getter. And you can see that polygon is a parent class, square is a child class, and triangle is also a child class of polygon. So polygon is one parent giving property to square and giving property to triangle. Now when I am passing the value of width and height in polygon, that will be accessed by square and triangle to get the area of a triangle and square. I created an object S1 for square. I set the values through setter. As I mentioned, I cannot set the values directly because these are like private variables. So I'm calling this setter and then I'm finding the area. Same way for triangle, I am setting the values again and then I am finding the area again for triangle. So this is one of the small quick example which you can use for mathematical calculations for any of the polygons. Right? Now, what else we have? So we spoke about objects, we spoke about class, we spoke about methods. We spoke about different type of inheritances as well, hierarchical, multiple, multi-level, single, right? We had a discussion about it. Then we'll talk about polymorphism, but before that we spoke about encapsulation as well, right? We are creating a variable which is nothing but private variable. So encapsulation is nothing but I am making things private, okay, which is one of the fundamental concept of object oriented programming language. The main purpose is it describes the idea of wrapping the data, right? Wrapping the data or a variable or a method, you can say, that is work within one, you can say one object or one unit. This basically helps us to put the restriction on accessing variables and methods directly and can prevent the accidental modification basically. That is the main purpose here. To prevent that accidental changes, we have to create an object variable that can only be changed by an object method, okay, and that variable is nothing but this private variables. So any variable you think that I don't want to change that variable, then I will go with encapsulation. For example, let's say I want simple example, RBI monetary rate. As of now, let's say RBI monetary rate is 7.5 and I don't want my function to change that value. What will I do? I will do encapsulation to that rate and that value will be fixed. Yes, double underscore is super private, we say normally. Now, what is polymorphism? Polymorphism is nothing but basically you can say that different, poly means what? Multiple. Morphism means what? Forms. So polymorphism is nothing but multiple forms. For example, let's say if I have, I'm taking one simple example. I have, let's say A is equal to 10 and B is equal to 20. A plus B will give me what? It will give me sum. Now, if I have A is equal to R and B is equal to T, then A plus B will give me what? It will give me RT, concatenation. So basically this plus is having different behavior for different types of variables. If I am using integers, then it is adding up the values. If I'm using strings, it is concatenating the value. And this type of concept is known as operator overloading. So in polymorphism, there is a concept of operator overloading. Okay. Now, if there is an operator overloading, then obviously we should, let's say I'm creating a class equal to book. Okay. Def init, I am calling self and pages. If we are saying that in Python there is an operator overloading, then we should able to add the books. Basically, let's say I'm creating B1, which is an object of book with 200 pages. B2 is a book as well with 100 pages. Polymorphism is nothing but multiple forms. This plus has multiple forms, right? When I have two numbers, I'm applying plus, it is summing up the values. When I have two strings applying plus, it is concatenating the values. This is known as operator overloading, which is part of a polymorphism. Now, if we are saying that operator overloading is valid in Python, then it should able to give me B1 plus B2 as well, right? But here we are getting an error. That means operator overloading is not possible. Maybe, may not be. Let's check that. There is a concept of magic methods. Operator overloading is very much possible in Python by calling the magic methods. Magic methods are nothing but what I want to do. I want to add two books. Two books are nothing but classes. I want to add the classes. obviously the objects which created from the classes. So def, this is my magic method add self comma other colon return self dot pages plus other dot pages. If I execute, you see we are getting 300. So basically what happened? B1 goes to self, B2 goes to other, and it is summing up the values. I can put anything here. You can put any name. Edureka, you can put, no issues. So that is how you can add multiple values as well using two methods as well, like two objects as well. Now question arises, can I able to sum up three books? If method overloading is there, then we should able to sum up three books as well, right? B1, B2, B3. Here I will pass B3. It should work. It is not working. It is saying that integer and book. What is integer? 200 plus 100 is giving me 300. That 300 is nothing but an integer which is getting the output. And this book 50 is nothing but a book which is an object, right? Now I cannot add integer plus book. So what is the solution? You may be thinking, okay, let's do one thing. Let's put other one and here plus other one dot pages. It will not work because add takes only two arguments. So this will not work. This is not a solution. Then what is the solution? What can be done? I will create here a variable total, and then total will have value 300, right? Return book total. Now book total is what? Book total is my object. So book 300 is what we are getting. So basically what we are doing is, when we are running this command, B1 is going to self, B2 is going to other, we are adding up the values, we are creating a book again, then this book total is going to self and B3 is going to other, and then two books will sum up. Okay, and now if I will execute, and obviously we have to convert to a string as well because we are adding two books, right? So if you want the output, it should be def str, which is again a magic method self. These are like constant, this cannot be changed, right? This is like, this is what you have to pass. Print str self dot pages. Something is wrong here. Str print, sorry, it should be written, not print. Okay, so you're getting 350. So from here we can clearly say that operator overloading is pretty much possible. That is one form of polymorphism. Okay, now there is a concept of method overloading. Now what is method overloading? Magic methods are nothing but these are the methods like add, we can have multiplication, all those things. You can get all the magic methods dir. So dir int. Okay, so when you run, these are the magic methods we have: add, bool, greater than, equal to, int. These are like magic methods we have. Okay, now there is a concept of method overloading. Now class test. Okay, def m1, which is my method inside the class, self print no arg. Basically here I don't have any argument, right? I am not passing any argument, so it is no argument method. I have one more method exactly same as the same name, def m1. Again, if you're asking that, a is my argument, print it is my one argument method, and I'm creating one more method m1 again, self a comma b, print. We can remove self as well, no problem. I already mentioned that. In this scenario, we don't require that. Self, sorry, print to arg method. Now I have three methods coming in with the same name in the same class. Now the question arises, t test, I'm creating an object. Will t dot m1 will work? T dot m1 10 will work? T dot m1 10 comma 20 will work? So basically all will not work. Only last one will work. Wanna see that? Let me execute the first one. Looking for A and B. So this is not working. Let's try this one. Looking for B. Also not working. Now it is working. Okay. Now question arises why? Because method overloading directly is not possible. We are overloading the method right here. I have m1. I'm creating same function with m1. Again same function with m1. That's why it will not run all the method. It will run only the last method. Now question arises, what is the solution? Can we solve that problem? Yes, we can solve that problem. How? There are two ways. Okay, I'll give both the options. Directly this way it will not work. That is, we already saw it. It will give me the last method as an output. Class test def sum, let's say self a equal to none, b equal to none, and c equal to none. Okay, I'm passing three values. If a is not equal to none and b is not equal to none and c is not equal to none, print. So basically I can sum three numbers because all are not none. So the sum is a plus b plus c. Okay, simple. But now question arises, if I pass only two value and I want to operate that as well, in that case what can be the output? If a is not equal to none and b is not equal to none, then print sum of a plus b. If a is not equal to none, print number a. Else print at least pass one argument. Okay, something goes wrong syntactically and is missing, and okay, now let's call t is equal to test. T dot sum, what will happen? What will be the output do you think will happen? T dot sum 10, what will happen? T dot sum 10 comma 20, what will happen? And T dot sum 10 comma 20 comma 30, what will happen? You can see that the values are perfectly coming in. But this is a very, you can say, coding wise, this is not a good method, right? Suppose I want to add four numbers, then I will add one more none. Let's say I want to add 10 numbers. It will be very difficult for me to handle that. Then what is the solution? Let me create it. Class test def sum self star a is known as variable argument. Okay, a is a variable argument. You can pass any number of variables. Total is equal to 0 for x in A. Total is equal to total plus x. Print the sum is total. Simple, right? T is equal to test T dot sum and pass the value 10 10 10 10 10, execute 10 20 30. Okay, so A star means variable argument. You can put many values here. Okay, so that is what my method overloading is. That is how you can do method overloading. Now question arises, there is a concept of constructor overloading as well. Class test def init, this is my constructor, right? We already know that it is a constructor. Self, let's say print no arg constructor. Def init self a print one arg constructor. Def init self a comma b print two arg constructor. Okay, now question is, if I will call t is equal to test, will this work? T is equal to test comma 10, bracket 10, will this work? Or T is equal to test 10 comma 10 10 comma 20, will this work? The last one will work, right? Obviously. Let's check that. Require two positional argument, so this will not work. This will also not work, and the last one will work. Perfect. Last one will work, obviously, why not? So it is known as, like, I'm basically calling three constructor, it will take the last constructor. So constructor overloading is not possible, looks like. But can we achieve that? Because when we are creating multiple constructor in a class, the last constructor works. That is the way how it works actually. The way, if you see here, right, we had a multiple methods and the last method ran. The same way applies here as well. The solution is, again, we have two solution. One is dot like star a, and second is that assigning none none none. That is the solution. So class test def init, okay, self comma a equal to none, b equal to none, c equal to none, colon, print, let's say constructor with 0 1 2 3 arguments, p equal to test. Will this work? Yes, absolutely. T equal to test 10, will this work? Absolutely. Will this work? Absolutely. Right, all are working fine. That is how it behaves basically, right? When we are creating multiple constructor, the last constructor will take the priority, guys. Now why it is so, that is the behavior of Python. Now the solution is, another solution which we have is class test def init self comma star a print constructor, right? I just printed like this. Now I can have various arguments, no doubt, no issues, right? T equal to test will work, T equal to test 10 will work, T equal to test 10 comma 10 will work, T equal to test comma 10 comma 10 comma 10 will work, right? And so on. No issues, execute. Perfect. Okay. Now there is a concept of method overriding as well. Someone asked me that if I have a child has the same method, same as parent. Let's take one example. Here is my parent. Parent says that I have property, please take it, The property is nothing but land. I will give you cash, I'll give you gold, and I am a prime minister, I'll give you power also. He also says that these are the three girls. You have to choose the girls from here for your marriage. The girls are X, Y, Z. You can choose any of the girls for a marriage. But now child says that, see, I want your property, right? I want your property, but I already have a girlfriend. So I will do a marriage. I have three girlfriends. So I will do a marriage with any of the girlfriends. Now what happened? Marriage is present in child also. Marriage is present in parent also. Now if I will create a class of C, and if I try to call marriage, property will come automatically because parent is very much eager to give the property. But in marriage, what will happen? Will I get XYZ or ABC? I will get ABC, obviously, because I'll get the property from the child, not from the parent. Okay. But now, let's say parent says that do one thing, choose girls from my options and from your options. You can choose out of 6 girls, whichever you want to marry. Then how will that work? So there is a concept of super keyword. So basically I'll get the property of parent also. So let me copy all this stuff. So I'm not writing it again. And here in marriage, I have already print ABC. If you want to marry my option girl as well, just call super and marriage. Super marriage will give me the property of parent class as well. Okay. So these are some of the concepts of polymorphism and method overloading, method overriding, all those things we have. Now the last concept which I want to talk about is abstract class, abstract method. Now if I want to define what is abstract class is, what is abstract method is, then how will I define it? So basically abstract method is nothing but method having no proper implementation. Okay, method having no proper implementation, then that is abstract. For example, I created one method but that is not completed, then I will make that as abstract method. How to declare an abstract method? There is a command called @abstract method decorator. There is a concept of decorator. So to create an abstract method, we have abstract method like this to declare that. And this abstract method decorator is present in ABC module. You have to call ABC module. And child class which we have is responsible for parent class implementation. Okay, so child will give the property. For example, let's say I have my parent and he want two-wheeler and he don't have two-wheeler as of now, like they applied for a loan, so it is at the middle and he wants two-wheeler from me, so I as a child will give, right? So that parent two-wheeler class or two-wheeler method is abstract method. Okay, now I'll take one example so that you will get an idea what I'm saying. Let's say there is a class called vehicle. Okay, and obviously I have to call ABC module is what I have to call if you want to call the abstract method. And this ABC, if you want to call, you have to actually write from ABC import star. Okay, obviously syntax error will come, I'll just clean that. You can see that it is ABC colon. Okay, I'll put the method, and this is abstract method. So in class vehicle there is an abstract method, so I can say, or let's say yeah, that's fine, I'll make it as abstract method def m1 self pass port. Okay, you see here vehicle has a method m1. As of now, nothing is happening in m1, right? It is halfly constructed. There is no logic present here. But there is a child. There is a child of vehicle. It consists of m1 and it has some logic. For example, just a print m1 logic present here. Okay. Now what my parent will say, see, I have one more property which is, let's say, def m2 self print property. Okay. It says that I have this property which I will give you, but in place of that, you give me this property. My m1 is not fully constructed. I want that m1 property from you. Okay. So that is what we can do. So let's say if I'll go ahead and create c is equal to c dot m2, m2 is working fine, c dot m1 is working fine as well. What will happen if we'll write vehicle? We have to create a class for vehicle, v equal to, you see here, cannot instantiate abstract class vehicle with abstract method m1. So this is not gonna work, but this will work through parent property, sorry, child property. Okay, so child is giving me the property, child is giving the parent the property m1. So m1 task which this guy has to do will be done through child. Suppose this class is also, this method is also abstract method, then what will happen? Abstract method is, sorry, abstract method, you see I'm getting c with abstract method m2. So basically what's happening here now, m2 property I am not able to get from the parent because m2 is also not properly built. You have to support your parent for creating that property also. And now you can see that we have, obviously this will not work. You can see that we are getting m1 and m2 logic built. So when my parent, the class is not created, the methods are not created, child is helping the parent, is what this abstract method is, because this abstract method is not properly built as of now. Okay, and that is what my abstract method is all about. And this is what I wanted to cover. All right, thanks guys, thanks a lot, stay safe and take care of yourself.